Over the last 20 years, palm oil has become the focus of international attention. High demand for palm oil has led to a large-scale cutting of the rainforest, and it is one of the most environmentally destructive agricultural crops worldwide. University of Colorado researcher Phil Taylor and a team of scientists and engineers have looked into ways to make palm oil a more environmentally sustainable product.
Palm oil is a common ingredient that's used in many household products that we all consume, that companies like Unilever, Procter & Gamble, Hershey's use in their common food ingredients. It's also popular for cosmetic use. It's a very versatile oil that is used for soaps and increasingly so for biofuels. And it's taking over and now is the largest oilseed in production compared to others like sunflower oil, canola oil, or soybean oil.
Palm oil is grown around the equatorial belt from Asia to Latin America. The common threat from these huge palm oil plantations is slash-and-burn agriculture, which is devastating tropical forest where carbon was once sequestered and is now released into the atmosphere. But there is hope, and CU Boulder researchers have been working to shed light on potential solutions.
One of the great ironies of the palm oil industry is that it's perhaps the most destructive agricultural crop that's currently being produced, but in many ways has the greatest potential to become sustainable. Palm oil production has a number of impacts on climate change. Before the palm oil plantation was there, it was a pristine tropical rainforest, containing maybe 300 megagrams of carbon in a single hectare. In the process of removing those forests to clear for agriculture, there's been a massive loss of biodiversity and many times harms to local indigenous groups. And that's created a lot of controversy over its sustainability.
Palm trees grown in large plantations produce palm fruit. Palm oil is then extracted from the pulp of the fruit, and in the process, large amounts of waste are created that is then stored in wastewater lagoons.
And it goes into these large lagoons that are about the size of a football field. It sort of looks like a chocolate oatmeal stout, although very, very stinky. And it immediately begins decomposing. And in the process, there's a group of bacteria known as methanogens. And these methanogens colonize the waste and convert a large percent of the organic content into methane gas. And that process is very vigorous and very rapid.
Methane is a powerful greenhouse gas, as much as 34 times more powerful than carbon dioxide. So, Taylor and his team began to ask this question. What do palm oil production and renewable energy have to do with the tons of rotting jungle waste that is a byproduct of these vast plantations? The answer is a lot.
I typically study primary old-growth tropical rainforests and their role in the global carbon cycle because they're the lungs of the earth. And I had an undergraduate student who was interested in working with me in Costa Rica, where my field station is. During the drive to and from the field station, she noticed that all of the vacated land was filling up with palm oil. She was really curious about how they handle their waste and deal with their waste.
That was really just kind of shocking, seeing how many plantations there were, even from the Google Earth view, and then we also saw the wastewater ponds.
What they discovered could reduce greenhouse gas emissions while providing energy for thousands of people, as well as industrial uses. And the solution is in the palm oil production waste.
We contacted a local palm oil facility, a cooperative in the southwest of Costa Rica, and we began researching the amount of greenhouse gases coming out of the methane wastewater lagoon, and we were surprised to find that it was a staggering amount. It represents a massive source of methane to the atmosphere and also represents an uncaptured source of renewable energy.
Methane emissions from a single palm oil mill can produce about 4 megawatts of electricity. With already over 1,300 mills across the tropics, this means a lot of energy for rural communities that typically rely on fossil fuels for energy. Taylor and Fancher shared their findings with the palm oil mill in Costa Rica, which inspired an investment in a palm oil methane capture energy facility. The power facility was recently completed and now provides renewable energy to the local community.
I think it becomes difficult to personalize the effects of climate change. You know, the closer we can create a connection between our actions here and the effects on the other side of the world, which are definitely tied together in the modern food system, I think the better we can start telling those stories and making those stories relevant.